Good morning, students. See, we are in VSAQs. Today I finished kinetic theory of gas from thermal properties of matter. Today I am giving VSAQ explanation from thermal properties of matter lesson. From this thermal properties of matter, you can get two VSAQs. Yesterday I finished kinetic theory of gas. Now thermal properties of matter. Then after one more lesson, two VSAQs lesson, mechanical properties of fluids. First, thermal properties of matter. Selected VSAQs you are reading. You can get two VSAQs from thermal properties of matter. This lesson weightage 8 marks. Two VSAQs, one SAQs. Sometime direct you can get one long answer direct. So thermal properties of matter, focus on both VSAQ zone. VSAQs left from thermal properties of matter. See here, one question, distinguish in between heat and temperature. Write any two difference from heat and temperature. Difference in between heat and temperature. Heat, temperature, number one. Just 2 points enough, student. For each and individual VSAQ, individual line, you can get 1 mark. Distinguish in between heat and temperature. Heat is the form of energy. Heat is the form of energy. It flows from hot body to cold body. This is the energy form. Temperature. Switch in between heat and temperature. Flows from hot body to cold body. Heat is the form of energy. It flows from hot body to cold body. Now, what about temperature? Degree of hotness or coldness of the body. 1 point difference in between heat and temperature. Heat is the form of energy, flows from hot body to cold body. Temperature, degree of hotness or coldness of the body. Heat unit, joules, SI unit, calorie, Celsius units. Temperature unit, Kelvin or degree Celsius or degree centigrade, anything, no problem. So, distinguish in between heat and temperature means you write 2 points, enough 2 points. Heat is the form of energy, flows from hot body to cold body. Degree of hotness or coldness of the body, nothing but temperature. Heat units, temperature unit, heat, measurement of heat with calorimeter. Calorimeter is used to measure heat. Thermometers are used to measure temperature. Like that we are writing differences. So 2 points enough. Next, number 2, what are the lower and upper fixed points in Celsius and Fahrenheit scale? Celsius and Fahrenheit, I gave this explanation in 4 marks. Celsius scale, Fahrenheit scale, LFP, UFP. Celsius, Fahrenheit, LFP, UFP. LFP means 0 degree Celsius. UFP means upper fixed point 100 degree Celsius. This one 32 degree Fahrenheit to 12 degree Fahrenheit. Overall, lower fixed point and upper fixed point from Celsius scale and Fahrenheit scale. Celsius scale means 0. Fahrenheit scale means 32 degree Fahrenheit. Upper fixed point means 100 degree Celsius from Celsius scale to 12 degree Fahrenheit from Fahrenheit scale. This is the Celsius cum Fahrenheit scale, upper fixed point, lower fixed point. Next, can a substance, this question came in previous examination, annual exam, can a substance contract on heating? Give example. Next question, can a substance contracts on heating? Means for this one, heating. For this one, answer yes. Example, students, you take rubber, Indian rubber, polythene cover, Indian rubber, water from 0 degree Celsius to 4 degree Celsius. One is yes, second one rubber, enough. Cast iron also there, one more. So one example enough. Can a substance contracts on heating? Yes, contracts. Polythene cover you take, leather you take, all this one contracts. Rubber, the best example and simple example. Why gaps are left between rails on a railway track? So in between railway track, gaps there. What is the reason for that one? Here. Here, why gaps are left between railway tracks means gaps to allow linear expansion in summer. To allow linear expansion in summer, meaning summer high temperature, effect of high temperature, that railway track expands. Again in winter season contracts. So this uneven expansion, we need gap, somewhat gap. Just you are writing why gaps should be left in between railway track means to allow expansion. That one also linear expansion in summer. Next question, why do liquids have no linear and aerial expansion? This one according to our textbook, question number 6. What is the question means? We are going only important question, student. Why do liquids have no linear and aerial? There is no shape, definite shape absent for liquids. For liquids, only volume present. That's why volume expansion there. Which one absent? Shape. That's why no shape for liquids, only volume. Enough. There is no shape, definite shape not there for liquids. Shape there means either length coming, area coming. That is why shape absent. That's why we are having only volume expansion coefficient. That one also apparent expansion, real expansion. You are not writing like this, no shape for liquids. It have only volume. Enough. That's why we are having only volume expansion coefficient. Next, latent heat of fusion, latent heat of vaporization. First, latent heat of fusion. See, the latent heat of fusion. The amount of heat, the amount of heat required for solid, nothing but ice. The amount of heat required for solid to convert from solid state to liquid state. What is the latent heat means? Heat required for a body to change its state completely. Solid state to liquid state coming. Ice, water, three states present. Solid state, ice we are calling, water, liquid shape, vapor, nothing but gaseous state. So heat required for substance to convert its state from solid state to liquid state. That is latent heat of fusion. Next, latent heat of vaporization. This one, water to steam. When we are taking solid to liquid, fusion word coming, the amount of heat required for water to change its state from liquid state to gaseous state, that is nothing but latent heat of vaporization. Both are same, solid to liquid, liquid to gas. This is the latent heat of vaporization. What is specific gas constant? Is it same for all gas? So next question, student. Specific gas constant. One more is there, universal gas constant. Our topic, specific gas constant. What is specific gas constant? Is it same for all gas? Gas to gas compulsory specific gas constant changes. What the question number means here? 9th. Denoted with small r. This is the specific gas constant. It is different for different gas. Ratio between universal gas constant with molecular weight. Just they are asking what is specific gas constant, is it same? So it is different for different gas. This is the specific gas constant. What are the units and the dimensional formula for specific gas constant? Units for small r. Joules per kg Kelvin. This is the SI unit, student. Otherwise, calorie per gram degree Celsius. This unit. SI unit enough actually. One time I am giving CGS units also with the dimensional formula. What is the dimensional formula means? Joules. M L square T power of minus 2. Kilogram means M, mass. Kelvin means K. L square T power of minus 2 Kelvin inverse. This is the dimension formula for specific gas constant. Joules per kg Kelvin, student, smaller units. Joules per mole Kelvin, that is for capital R. Our topic about smaller specific gas constant. So specific gas constant with dimensional formulas over. Next, why utensils are coated black? Yes, yesterday we discussed black bodies. Black bodies are good absorbers. So first of all I am reading question. Why utensils are coated black? Why the bottom of the utensils are made of copper? Simple. For this question, why coating black and why we are using copper? Question number 11. Black bodies are good absorbers of heat. No, yesterday we discussed a body good observer means good emitter. A body poor observer means poor emitter. This point given by Kirchhoff. Majority people thinking that Kirchhoff laws in electricity, but Kirchhoff scientists explained thermodynamics concept also. Black bodies are good observers of heat, and why we are using what is that? Copper means copper. It absorbs uniform heat and it gives to the vegetables cooking purpose we are using now. That's why. Yes, question number 11. Coated black. Why we are coating black utensils means black bodies are good absorbers of heat. This is the one reason, student. And one more is there. Why the bottom of the utensils are made of copper. Copper absorbs uniform heat and gives cooking. When we are using cooking time, uniform absorptions take from copper. That's why two different materials we are using, student. What is the similar point in between two points, two materials means both are good absorbers of heat. Next, ventilators are provided in the rooms just below the roof. Why? You know, ventilators. Why ventilators means purpose? We want to remove hot air out. When hot air going out, automatically cold air coming. That's why question, why? Oh, here one more means displacement. Okay. Ventilators are provided in the room just below the roof, meaning hot air rises up. Hot air, nothing but there is a low denser. Hot air rises up and cold air. Otherwise, you write direct. This one dimension formula. See, fourth one. See, what is the see student? Why that ventilators are provided in the rooms just below the roof means hot air obviously low denser. So we are writing question number 13. Hot air low denser, it rises up due to convection. Enough this answer. Due to convection, because total three modes there in transfer of heat. Heat transfers in between substance in three ways. I already gave this one 4 marks explanation. Conduction, convection, radiation. Convection means fluids. So hot air going out from the ventilators with respect to convection phenomena. That's why hot air rises. When hot air going up, automatically ventilators are up only, just below the roof. That is the reason overall hot air low denser. It rises up due to convection. Enough. So convection phenomena, hot air going outside from the room. That is the meaning of this one. Next, Wien's displacement law. Wien's displacement law. What is the Wien's displacement law means? Like this. Maximum wavelength of radiation. Wavelength inversely proportional to absolute temperature. Maximum wavelength of radiation inversely proportional to absolute temperature. Now this one, if possible, you write like this also. On removing proportional, we can get constant 2.3 into 10 to the power minus 3 meter Kelvin. So if possible, you write. Otherwise, up to your enough student, you are going. This one enlarging means this one enough, because one statement, one formula. Again, you are writing constant units. You are not writing means you are losing mark. Just wavelength of radiation inversely proportional to absolute temperature. Point number 1. Next, lambda m inversely proportional to T. 2 lines, 2 marks. Remove proportional, means constant. Again, units that one all excess. This 2, 12th and 13th. Does a body radiates heat at 0 Kelvin? Question mark. Does it radiate heat at 0 degree Celsius? Where body radiates, one is see, one is the 0 Kelvin. Next one is the 0 degree Celsius. 0 Kelvin means body does not radiates. I will give explanation what is the meaning of this one. Body radiates at, just body radiates. Students, now see here, what is the meaning for this one means, in our daily life where substance present, 0 degree Celsius means this one very common example. What is that? Ice. Ice means pakka 0 degree Celsius. 0 degree Celsius means body radiates, body parameters, everything present at 0 degree Celsius. That's why 0 degree Celsius body radiates. What about 0 Kelvin means, practically this value minus 273.16 degree Celsius. This much temperature, anything not possible. Every parameter equals to 0. Pressure 0, volume 0, temperature, everything 0 at 0 Kelvin. That's why body does not radiate at 0 Kelvin. This is the question number 14. And now see student, next, greenhouse effect, global warming. All this are important question we are going. One is the greenhouse effect, global warming, Newton law of cooling, roof of the building painted. Okay, more 2 questions there, most important. One is greenhouse effect with global warming. This one last VSQ, previous examination, this question came. One is the greenhouse effect, second one is the global warming. See student, both are same on this one. Greenhouse effect, this one most important concept for all science student. And greenhouse effect and global warming. You know, greenhouse effect means student, greenhouse gases, carbon dioxide, methane, CFC, chlorofluorocarbon. For example, just I am giving explanation. Sun, this is earth. Sunlight incident on earth. Sunlight transferred, sunlight moving in all directions. Sunlight incident on every planet in solar system. For example, sunlight incident on earth. Earth absorbs radiation from sun. Again here gases there. So greenhouse gases. Greenhouse gases means, for example, carbon dioxide. Greenhouse gases absorbs radiation from earth. If you remember, they are missing here. That's why I am saying sunlight incident on earth. Earth absorbs radiation. Then after again radiation coming, because just now I said a body good absorber means good emitter. That's why greenhouse gases absorbs radiation from earth, coming from earth, re-radiates. Automatically average temperature of earth atmosphere increases. That is greenhouse effect. What about global warming means, effect of this greenhouse effect, temperature, average temperature of earth atmosphere increasing. That is global warming. The process of rising temperature or the process of rising temperature, average temperature of Earth atmosphere, that is global. Every 10 years, 5 to 7 degrees Celsius temperature increasing. See, now here, student, now greenhouse effects here. I am writing greenhouse effect. Greenhouse effect. Don't think greenhouse means green color. See, greenhouse gases, carbon dioxide, methane, CFC, chlorofluorocarbon, absorbs radiation from Earth surface. Again re-radiates. The process of rising temperature of Earth atmosphere. The process of rising temperature of Earth atmosphere is global warming. So this question, greenhouse effect with global warming, recent annual exam question, student. Then after this Newton law of cooling, all this one you are reading long answer, that's why I am not teaching student. See, the roof of buildings are often painted white during summer. Why? You know, in our daily life we are calling cooling paint, Asian paint, like that, different companies coming. Cooling paints nothing but white color. What is the reason for that one? White bodies are poor absorbers. Poor absorbers always poor emitter. For example, this is your building. Here you coated with white. Don't think this marker color black means black color, you treat white. Sunlight coming. Sunlight incident on this building coated with white. This one acting as a reflector. Meaning when we are using white color paint, cooling paint, this room protected from high temperature. That's why white bodies are poor absorbers and poor emitter. White bodies acting as reflector. The answer. Now we are writing. See. Poor absorber. It acts questions from thermal properties of matter. So student, up to now 4 VSQs over. One from kinetic theory of gas, one from thermal properties. One means lessons. Kinetic theory of gas 2. Thermal properties of matter 2. Total 4. Now I am giving one more lesson, that is nothing but mechanical properties of fluids. From this one you can get 2 VSQs. See. Define average pressure, mention its units, dimension formula. It is scalar or vector. This many points they are asking student. First, pressure, average pressure. Just P average equals to this enough. The ratio between normal force acting normally, ratio between force with respect to area, force acting on the given surface with respect to the area. This is force. Mention units and dimensional formula. Unit direct we are going based on scientist name Pa. Pa nothing but Pascal. Normal force with respect to area Pascal, and one more next dimensional formula force M A L T power of minus 2 L square L cancel M L inverse T power of minus 2. This is the dimension formula. There is no specified direction for pressure acting in all direction, that's why scalar. This is average pressure definition, units, dimension formula, scalar. Normal force per unit area. See, next. Define viscosity, what are units and dimensions? Viscosity, student, viscosity, nothing but a viscous force. Anywhere viscosity word coming means friction. Friction, resistance, viscosity, all this one same terms. In intermediate, second year, electric resistance coming, of course, in 10th class also there, resistance. So what is the meaning of viscosity? Means opposing force. For example, you are going on bike, suddenly speed breaker coming, that is friction. What is the importance of speed breaker? Means speed breaker coming means we are decreasing our speed. The speed of vehicle automatically decreases. That is speed breaker purpose. Same viscosity. Question: define viscosity. Means viscosity means a force which opposes the relative motion in between layers. So in between the layers one opposing force is there, that is only viscosity. Here what is the viscosity? Units and dimensional formulas. Now see, units means Pascal second, student. See, this is the formula. Don't write formula, just dimension formula purpose I am writing. Pascal second, CGS units means poisonly. Here dimension formula means see, M A L T power of minus 2. Area means L square. L T inverse. M A force means M mass L T power of minus 2. This is the force dimension formula. Area dimension formula. Velocity dimension formula. Again L. Distance LL cancel. So what is the dimension formula? Means M L inverse T inverse. The force M into A for acceleration, LT power of minus 2. A for area, velocity means LT inverse, distance means L, L cancel, 1L cancel. Going up L inverse, minus 2 plus 1 means minus. So this one don't want student, direct M L inverse T inverse is the dimension formula for viscosity. What is the principle behind carburetor of an automobile? You know, every automobile is working under Bernoulli's principle, student. This is the question number 3. So enough this word. If you remember thinking this much shortcut we can get 2 marks or not, 100% you can get 2 marks because this one only scheme of evolution points. What is the principle behind the carburetor of an automobile? Means Bernoulli's principle. Next question number 4, Magnus effect. Magnus effect means student spinning ball. Dynamic lift acting on spinning ball. Dynamic lift acting due to spin. One ball under spin position means dynamic lift acting. That one only Magnus effect. So for Magnus effect, dynamic lift due to its spin acting on a ball. That is the only dynamic lift we are calling Magnus effect. Why drops and bubbles are spherical in the nature? You know, one and two reasons compulsory. First one is surface tension. Due to surface tension, bubbles spherical in the nature. Next one, for given volume, sphere has minimum surface area. Minimum area possible for sphere, spherical shape. For given volume, sphere has minimum surface area. About these two reasons, always bubbles spherical in the nature. This is the question C. This one water drop. Why spherical in the nature means one is surface tension. Second one is for given volume, sphere has minimum surface area. That's why due to gravitational pull, we are getting like this shape. Question number 6. Give the expression for the excess pressure in liquid drop. Question number 6. Excess pressure, liquid drop, and one more is there, air bubble. Student, this one both are same. That's why I am writing air bubble and liquid drop 2T by R. T nothing but surface tension, R nothing but radius. So we are writing 2T by R. This formula same for liquid drop and air bubble. Okay. And one more next upcoming question. Soap bubble. Pakka this question is Rayas. Soap bubble. Give the expression for soap bubble. Soap bubble means inside and outside surface present T equals to surface tension, R equals to radius of bubble. This is the 8th, 9th one also over. Now see, angle of contact, student. One more question. That water proofing agent, water wetting agents means which one increases angle of contact, which one decreases angle of contact. That one slide like what is the angle of contact? Listen carefully. This is the angle of contact. Now definition there. If you remember writing angle of contact 0 for water and glass, 140 degrees for mercury. This one all unnecessary because they are asking just what is angle of contact. Now see, like this there. This is the angle of contact. Angle made by the tangent. Tangent means imaginary line. Angle made by the tangent drawn from. Angle made by the tangent drawn from contact surface of liquid C. One minute, student. Madam. Madam. Yes, madam. See, 1 minute, student. Wait. Okay. We'll continue next class, student. Some technical problem came. Right.